Okay, welcome aboard everyone. Today we're going to be learning about increasing and decreasing functions and the first derivative test. That pretty much just means where we're going to find minimums and maximums on our graphs using a derivative. I know, it sounds terrifying. I have a couple examples here. Our first example, the equation is f of x equals x cubed minus 8x squared. Our question is asking us to determine the intervals where f is increasing or decreasing. We actually might go a little bit over that and figure out the minimums and maximums on the next page as well, but it's all in the same table, so there should be no problems. So the easiest way to do this, as you guessed by the first derivative test, is to take the derivative. So we're going to start off by taking the derivative. We're going to use the power rule instead of going through the x plus h nonsense. And we're going to have 3x squared minus 16x. Pretty straightforward. To figure out your critical numbers, it's wherever your x is 0 or non-existent. You learned that in a previous chapter. Feel free to go back, check that out if you don't remember. For this one, our critical numbers are going to be 0 and 16/3. You could write that if you wanted to as 5 1/3, if you're a mixed fraction kind of person. I'm not. So I'm going to continue with 16/3 on this next slide. The first thing you have to do, as you can tell by my beautiful table, is to make a table. I find that it's pretty nice to write down all the information on the left side so you don't forget it. For this one, there's no closed interval, so we start at -infinity. And it gets kind of old to write like this, but you get used to it. And it's your first critical number. So if you remember, critical numbers are 0 and 16/3. And then you say 0 is less than x is less than our other critical number. It's important, obviously, that you go from the smallest number to the largest number. Otherwise, you're going to get some really weird intervals. And our last interval is 16/3 to infinity. That's an x if you can't tell. Now you have to pick a test value. I know I just wrote test. Sometimes I write TB. It's any number within the given interval. So if our interval is from -infinity to 0, it's basically any number less than 0. You could pick any number, any decimal, any fraction. You could pick -pi if you wanted to. I find it easiest just to pick a number like -1. For here, we know it's 5 1/3. I'm going to pick, don't even know what I'm writing. We're going to pick 1. And over here, we're going to go with 6. Again, you can pick whatever test values you want. It's just my personal preference. You're going to plug in, see where it says f prime of x? You're going to plug your test value into f prime of x, so into your derivative that you found in the last slide. For this one, you'd be plugging it into, if you remember, 3x squared minus 16x. So that's your f prime of x. That's terrible. You know what I mean. Yeah. There. So you're going to plug in your test values into that. I'm not going to do the math. I assume you can plug it into your calculator on your own. We find out that the sign is positive, negative, and then positive. You could write down the actual number if you wanted to, but it's a lot less confusing to just have the sign. Because if you're getting used to the table, you might end up accidentally plugging that number in for somewhere it's not supposed to be. And this is really all you need. Here your options are increasing and decreasing. For the positive, it's increasing because the slope is positive. The derivative itself is positive. That's exciting. Okay, so that's increasing. Don't know what's happening in there. This one's going to be decreasing, and this one over here, again, is increasing. So you can draw a little graph. It goes up, and then it goes down. This one starts by going down, and it goes up. So right here, you see a change in slope. Obviously, it hit 0, it's up some point in there because that is why you have your critical numbers. So you have a maximum and a minimum. Like I said earlier, this isn't included in the instructions of the problem, but I think it could prove pretty helpful. To figure that out, what the actual point is, you'd plug in the critical number at which it occurs into your original function, and it would give you something like that. It's pretty straightforward. That's all you need to know for example 1. Now for example 2, we're using trigonometry, so it's a little bit harder. You should know by now that the derivative of sine of x is just cosine of x. It's one of the easiest ones to remember, and it's pretty easy to work with too. If you look up here though, you can see that we have a closed interval. So instead of starting at negative infinity on the next page, we're going to start at 0. So keep that in your little noggins. For the critical numbers on this, all you have to do is look at a unit circle, and it'll give you the critical numbers. So wherever it's 0 or undefined. So there are lots of critical numbers, obviously, for cosine, because it goes on and on. Just goes up and down, and all of those would be critical numbers. So the interval helps us to limit it. So we just pick critical numbers within our interval, which in this case would be pi over 2 and 3 pi over 2. Then you move on to your table that you drew so nicely. Again, your critical numbers are pi over 2 and 3 pi over 2. There you go. And our interval, if you remember, we have a closed interval, so it goes from 0 to 2 pi. So our first interval is going to be 0 is less than x is less than pi over 2. Our next one is going to be pi over 2 again, is less than x is less than 3 pi over 2. Finally, it's going to be 3 pi over 2 is less than x is less than, and remember, closed interval, so it's 2 pi. In non-trigonometric problems, you're probably not going to have a closed interval very often, but you might, you never know. For a test value, again, you could pick any number you so please. I find it's easier to pick something on the unit circle. So I went with pi over 4 for this. I just went with straight pi, and then 7 pi over 4. You could plug in the actual numbers. You could write those down. I'm just going to go plus, minus, and plus. It's a lot easier to not go around in circles. Next, you have to write if it's increasing or decreasing. So we know a plus means it's increasing, a minus means it's decreasing, and a plus again means it's once again increasing. You can draw your little graphs. That's what your graph would look like at those points. To find your min and max, all you have to do is look at your little pictures and plug in your points. So you know that this one is at pi over 2 something. So you plug it in and you find out it's at pi over 2, 1. This one's at 3 pi over 2 something. You go to your handy dandy calculator and you plug it in. And it's 3 pi over 2, negative 1. So for pretty much any question that you are asked that has to do with this section, if you fill out this beautiful table up here, it'll pretty much solve all your problems. Sometimes this is required if they're asking for actual minimums and maximums, but you get all your information from the one table. And that's all. That's all you have to know for this section. Have fun in the next one. Don't get too discouraged, and good luck calculating.